YouTube. Okay, where am I? So today I'm gonna solve some problems on DP, and last time we have already done problem on subsequences. Okay, we have done this question also. Yeah. Okay, I will take care about that DB knapsack problems later on, but I think I should move on to the next type, strings, and I have stokes and lists. LIS, what is this? What does that mean? Longest increasing subsequence. Okay, MCP and DB. I think a string is important because there's lots of question strings. If I can know about what are these questions. So okay, that's the longest common subsequence problem in DB. I think I should watch a video before starting any problem from the problem on string to grasp the idea how I'm gonna solve that. And then I have longest palindromic subsequence minimum insert DP minimum insertion string subsequence. Print a longest common subsequence. Okay, so here is the problem longest common sequence, and here we have to print the longest common subsequence. Okay,
Hey everyone, welcome.
print longest common subsequence on DP on strings. Okay, so here I have longest common subsequence, top down, bottom up, and space optimize all the things that I need, and longest common substring, print longest. Okay, here printing one. Here this is I think this is important, uh, and then I can solve these questions, I guess. So I just watch this video.
Hey everyone, welcome back.
But before that, I think I should try a typing. Why not? No way. What? This by you? have no. So if I'm telling you about my plan, what how I'm gonna learn after DP, I think try some questions on uh, these sections like string and stroke LIC. Then I will go back and go back in the starting and try to attempt question of array string, the important question where the company that asks more often. That's my plan. Why I Okay, I'm gonna go very slow and try to not make what the hell use large again the old house life word show follow we stand no no 45. Not bad if I say how slow I went. Okay, got it. I even make mistakes when I'm deleting a word a character. I can't reach up to the backspace. Day up. What? In a single moment, 3 mistakes. No, that's 2 mistake there. I just might. Okay. I'm making mistake while typing. Okay, I have to type the words where I'm mistaking. I forgot every time. In the end, I should use the error feature. No, right lead public What? Okay, so when I'm concentrating on my fingers, like I'm looking at the screen, but concentrating on where my finger goes with my mind, and think when uh, when I make less mistake. 47 please. हाँ. I think this is enough a miserable act. Let's move on to the video. Okay, let's see what he got here for me.
Back to take you forward. We will be starting off the new pattern, that is DP on strings. Okay, generally in DP on strings, you'll find problems of comparison, you'll find problems of replacements, edits, etc. So these kind of patterns is what we will be solving, and we'll be doing a bunch of problems. And again, when we complete DP on strings, you can solve any problem on DP on strings. That's my guarantee. So to start off with, let's take the first problem, which is longest common subsequence. Yes, but before understanding that, let's understand this term subsequence in depth. What is subsequence? So if I write ABC,
The problems like comparison. In comparison means like you have to compare two strings and check whether it has the other strings, like a smaller subset string that present in other string, and have the similar two string. I think that's oh we you would what a second replaces and add it. Okay, replacing the edit. Longest common subsequence. What subsequence? Wait. Okay, let's start. Where
A is a subsequence, B is a subsequence, C is a subsequence, AB is a subsequence, BC is a subsequence, AC is a subsequence, ABC is a subsequence, empty string is also a subsequence. What is a subsequence in a string S? You see BC, repetitive, BC is consecutive, and maintaining the order of B and C, maintaining the order of B and C. You see AC, AC is not consecutive, but maintaining the order of AC. ABC is consecutive and maintaining the order. Very simple. It can be consecutive, it cannot be consecutive, but as long as it maintains the order in the string, then you can call it as a subsequence, right? And in order to print all these subsequences, you might be thinking, Trevor, how do I print all the subsequences? So in order to print all the subsequences, you can use either power set, I have a video on this, or you can use the recursion method. Again, I have a video on both of them. And if you watch the video, for any given string, like this string is of a length 3, and the number of subsequences is 8, including the empty one, where I say I do not pick any one. So for a string of length to n, the number of subsequences is 2 to the power n. Okay, so that is what subsequences mean. So what is longest common subsequence? What does this signify? What does this term signify? So I can say over here, A, D, E is a subsequence.
again? Okay. Okay, like here we have uh, a string ABC, and how can I find out the subsequences of ABC? They can be A, B, and C, A, B, B, C, and AC, and ABC, and the empty. Subsequence is a sequence wherever the uh, string or array have the subset of that string, but the sequence will be same. Then we can call it subsequence. Maintains the order. Yeah, that's I mean maintains the order of a string. You can find using the PowerShet and the recursion also.
String of length to n, the number of subsequences is 2 to the power n. Okay, so that is what subsequences mean. So what is longest common subsequence? What does this signify? What does this term signify? So I can say over here ADE is a subsequence, ADB is a subsequence, AEC is a subsequence, DBC is a subsequence, EC is a subsequence, DC is a subsequence. There can be 2 to the power 5 subsequences, 32 different subsequences. Similarly over here there can be 32 subsequences. Okay, so I can say this guy can generate 30 plus 32. DBC is a subsequence, EC is a subsequence, DC is a
ADEBC, that's a first string. We have and as to DCADB, that's second substring. We have
subsequence. There can be 2 to the power 5 subsequences, 32 different subsequences. Similarly over here there can be 32 subsequences. Okay, so I can say this guy can generate 32 subsequences, namely A, D, E, B, C, A, D, A, E, A, B, A, C, and so on. And this guy can also generate 32 subsequences, correct? Namely D, C, A, D, B, D, C, D, C, D, A, D, 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 B, and so on. Now what you need to do is, you need to take this A. Does this A exist? Yes. So as of now, the common subsequence, one of the common subsequences is A. Does D exist? Yes. One of the common subsequences is D. Does AD exist? No. So AD is not a common subsequence. Does AC? No. Does AB? No. Similarly, you have to go on writing, and you will see ADB exists over here, ADB, and ADB also exists over here. So you'll find ADB is common in both of them. And you have to find among all common subsequences, which one is the longest. So ADB is the longest that you find. Yeah, there was A, there was D, but you need the longest. So the longest is ADB. And what is the length of this? 3. The length of this is 3. So you need to tell me the length of this, which is 3. So that's the question. Pretty straightforward. Now you might think, Strago, let's apply brute force. Okay, that's correct. What's the brute force? Generate all the 32 subsequences. You might think, Strago, let's apply brute force. Okay, that's correct. What's the brute force? Generate all the 32 subsequences. Generate all the 32 subsequences on this side, and then do a linear comparison of both and find manually which one is the longest. But in order to do that, you have to actually generate all the 32 subsequences, because generate, take one, compare, take one, compare, take one, compare, take one, compare, and get the longest among them. That's going to be 2 to the power n, because you have to generate all of the subsequences exponential in nature. So the brute force is going to be exponential in nature. Hence, a pattern that I will not follow. But yeah, if you want to generate all the subsequences, feel free to watch out the PowerSet video or the recursion video that I will be leaving the link in the description. Okay, so if not brute force, then what? Then my brain says, okay, let's let's generate all the subsequences and try to do comparisons. Okay, generate. That's what we did. Generate all subsequences and compare on way. That's what I'll think, and that's a standard way. Like you have to generate all subsequences and compare on way. That's a standard way that we generically do in recursion or like and on DP on strings. I'll be telling you about that. So you will be tending to follow a recursion method where you will not generate these. Instead of that, you will use parameters to generate them. I'll be showing you how. So first, let's understand. Instead of that, you will use that. So you will be tending to follow a recursion method where you will not generate these. Instead of that, you will use parameters to generate them. I'll be showing you how. So first, let's understand something in deep. Let's take an example super quickly. ACD and CED. Okay, assume these are the two strings that you're looking for. ACD and CED. Okay. Now, if you go to generate all the substrings, it'll be ACD, AC, AD, CD, ACD, and over here it'll be CED, CE, CD, and ED, CED. Then you figure out the longest being CD and CD. So thereby this is the longest which is of length 2. But if you generate this, that doesn't make sense. That's why we will try to write some recurrence. Yes, we'll try to write some recurrence that probably gives me the answer through the way. Through the way is my question. Okay. So assume you're solving this entire portion, this entire string and entire string. Okay. And generically, what are the rules to write the recurrence? Let's quickly just jot down the rules to write recurrence, and then we will try to follow those paths. Express everything in terms of indexes. Explore possibility on that index. That's it. Explore possibility on to write the recurrence. Let's quickly just jot this entire string and entire string. Okay. And generically, what are the rules to write the recurrence? Let's quickly just jot down the rules to write recurrence, and then we will try to follow those paths. Express everything in terms of indexes. Explore possibility on that index. That's it. Explore possibility on that index is what we do. Take the best among them because you're looking for longest. Take the best among them. These are the three rules that you generally follow. Now, express everything in terms of index. Okay, so either you can carry this entire string, or you can say, hey, listen, probably I can have a pointer here. Let's understand. Okay. So either you can carry this entire string, or you can say, hey, listen, probably I can have a pointer here. Let's understand. Probably I can have a pointer here, which is somewhere around index 2. And f of 2 signifies the string till index 2. Okay. Probably you can say I can keep a pointer here, which is again index 2. F of 2 again signifies the string till index 2. Something to observe. A single index cannot express both the strings. A single index cannot express both the strings. Thereby, I will have to represent them by two indexes. I have to represent them by two indexes where index 1 represents this guy, index 2 represents this guy. That's the first modification that you have to do in the rules. Since you're dealing with a couple of strings, you express them in terms of index 1 and index 2. Very simple. Like in all the array problems, you express everything in terms of index. Because there was an index, then you decided to pick and not pick or similar kind of things you did. Over here, we will have index 1 and index 2, which will be representing. So, can I say, if I omit this, and I write this something as f of 2, 2, or rather, let's write it in a smaller way. F of 2, 2, what does this represent? Tell me the LCS of string 0 to 2, string 1, 0 to 2, and string 2, 0 to 2. This is what this f of 2, 2 will represent. So, we have understood the expressing term. We have understood the expressing term. That's done. If I'm writing something as f of, let's say, 2 and 5, what does this signify? This signifies give me the longest common subsequence between string s1 0 to 2 and string s2 0 to 5. A smaller string and a larger string. This signifies this. So I hope you have got an idea what I'm meaning to say by index 1 and index 2. Okay, so this we have figured out. Now time to explore all possibilities, because if you do not explore all possibilities, we will be having an issue. Okay, so let's try to explore all possibilities. Okay, let's try to write them. So can I say this? That okay, let's try this. I'm having the string ACD and CED, and I'm having a couple of pointers over here, and this is index 1 and this is index 2. So a very straightforward question is, if they're matching, because this D, like, do comparisons character-wise. Remember this. Do comparisons character-wise. So this D and this D is matching. That's something we can see. This D and this D is matching. So can I say, if I just do not think of these things, and this D and this D is matching, can I say I got a subsequence of length 1? I got a subsequence of length 1 that is D, which is common in both of them. Okay, makes sense. Thereby, I can probably say one of the possibilities that I can have is I got one subsequence of length, and then I shrink the string. And I shrink the string and say the new string is AC and CE, in which probably you can find an answer. So does that make sense? It does. Because if these guys are matching, now you just have to take these two strings and ask them what's the longest common in them. Because I've done for D, which is 1. What is AC? I said you what is AC. This index will come here, which is index 1. So I can say AC is index 1 over here, CE is index 2 over here, which is nothing but f of 1 comma 1. F of 1 comma 1. Why f of 1 comma 1? Very simple. Because 1 for this t, and I shrink the string. This is the string, so that's f of 1, which means 0 to 1 is the string, and this du2. So again 0 to 1. So f of another 1 is there. That's how you can do it if they are matching. So if character matches, index 1 matches with index 2, can I write this as, I'll add 1 to the answer, and I'll reduce index by 1 and the other index by 1 as well. Can I say this? I'll reduce index 1 by 1 and index 2 by 1 as well. And this is going to be the recurrence if both of the guys are matching. Okay, so we have probably done one possibility. We've done one possibility over here, which is if both of the guys are matching. Okay, so we have probably done one possibility. You've done one possibility over here, which is if both of them are matching, then it's kind of very simple enough. You say 1 plus f of index 1 minus 1, index 2 minus 1, and that's going to be the case if match on indexes. If match on indexes, that's one possibility. Okay, now what about the other possibility? Because what if they do not match? Because in all the string problems, in all the comparison of string problems, you'll see match and not match, match and not match. In previous problems of arrays, it was pick, not pick. Over here it will be match, not match. So for matches, you'll generally add to the answer and it'll move back by index. In matches, you'll generally add the answer and move back by index. Similar to pick when you moved one back. Okay, so what about non-match? Let's talk about non-match. What if they're not matching? Yes, what if they're not matching? Because in the next step, it'll be AC and CE. What if they're not matching? Let's see. If I have AC and CE and they are not matching, something I know for sure is, if I go ahead, this C will match with the C. But as of now, my index 1 is standing here, my index 2 is standing here. So how will I go and compare this C and C? Because as of now I'm standing at E. If I move them both back, I will miss out on a comparison of C. I'll miss out on a comparison of C, right? Or what if there was an E here? So this E would have matched with the C. So I can also miss out on a comparison of E as well. You understood? If I had EC, then what will happen? This C and this C might match because they're standing in the other places. Or this E and this E might not match anyway because they're standing at different places. Thereby, you have to apply your brain. You have to apply your brain in such a way that you explore both the possibilities. Yes. What are both the possibilities? You say, hey, listen. For example, let's do it easy. You will say, hey, listen. Let's do one thing. Let's move only one guy. We're like, okay, but which guy? Let's try both. Because in both the directions, you might find the answer. I'm like, okay. This C did not match with E. Did not match. But this E might match with the C. I'll be like, okay, this C did not match with E. But this E might match with the C. Let's do one thing. Let's move the index 1 only. Let's keep the index 2 as it is. And since they're not matching, the answer added to the longest will be 0. Okay, makes sense. I'm like, that does make sense because I'll just move this index. I'll keep it because this guy might match in future with these guys. Okay, but then you'll miss out on the C. Then, okay, let's take the other way as well. When I say, okay, listen, let's keep EC. That means let's keep index 1. Let's move C. Let's move index 2. Let's move index 2 here. Okay, makes sense. Now the C and C might match out. Why? Because of match on indexes. In the next step, E and D will go on match on indexes. C and C will go on match on indexes. And over here there's a plus 0, that's sure. But did you understand what I tried to do? I said, hey listen, if they're not matching, let's either move this or either move this. There's both the possibilities. I'm like, okay, that makes sense. So can I say, if not match, then the answer added will be 0 for sure because there is no length that you're matching. Okay, plus f of index minus 1 is what you'll go. Sorry, index 1 minus 1 is what you'll go. And you'll keep the index 2. Or you'll keep the index 1 and you'll go the index 2 minus 1. And you'll take the max of both the guys. Yes, you'll take the max of either this guy or either this guy. And you can easily just move this or you can easily move this. And the max of this and this is what you will get the answer. Like either solve this guy or either solve this guy. Whichever gives you the maximum answer is going to be the max answer. This is what if not match will be. So we have also explored all possibilities on that index. Maximum answer is, and this is what you will get the answer. Like either solve this guy or either solve this guy. Whichever gives you the maximum answer is going to be the max answer. This is what if not match will be. So we have also explored all possibilities on that index. Take the best among them, you're taking the best among them. You either take on match, you either take this, and if they do not match, you take the best of this or this. So you've also done take the best among them. So that's how you can easily think in terms of DP on strings. I'll be drawing the recursion tree, don't worry about that. But that's how you can easily think of DP on strings. What are the base case? We will think about that. Let's try to write as of now the code in short, and then I'll think about the base case. So I'll be like, okay, f of index 1 and index 2 is there. That's for sure. Let's forget about the bases. What are the bases? Possibilities. Match or not match. Okay. So if they match, can I say if they match, then it will be index 1 equal to index 2. Okay, and what will be the answer? The answer is very simple. 1 of f of index 1 will also move, index 2 will also move, and you can easily return them. So if this line executes, the program returns over here and it goes back. The rest lines will never execute. Remember, if this program returns over here and these lines will not be executed. So I'll write the next lines. What are the next lines? The next lines will be very simple. I'll be saying either if this is not happening, and it goes, index 2 will also move, and you can easily return them. 1 and index 2 is there. That's for short. And then I'll think about the base case. So I'll be like, okay, f of index 1 and index 2 is there. That's for sure. Let's forget about the base case. What are the cases? Possibilities. Match or not match. Okay. So if they match, can I say if they match, then it will be index 1 equal to index 2. It can be. And what will be the answer? The answer is very simple. 1 of f of index 1 will also move, index 2 will also move, and you can easily return them. So if this line executes, the program returns over here and it goes back. The rest lines will never execute. Remember, if executes, the program returns over here and these lines will not be executed. So I'll write the next lines. What are the next lines? The next lines will be very simple. I'll be saying either if this is not happening, that means no match. If no match, can I say the answer will be 0 plus I will move the index 1 by 1 and I'll move the index 2 minus 1. Sorry, index 2 I'll keep it like this. Or I will be keeping the index 1 and I'll move the index 2 by 1 and I'll take the max of the best of them. And that's what I will return. If they're matching, it's fine. If they're not matching, then take the max of these couple of guys and return. So I just write it in a sophisticated way. In a sophisticated way, it will look something like this. Like 0 plus 0 doesn't have any significance. This one not match, this one match. As simple as it can get. So that was about the possibilities. But what is the other thing that's remaining? That's base case, yes. That's something which is base case. Let's think about the base case. So can I say, when will the base case come? Okay, let's come back and see. When will the base case come? Can I say, I'm a T. At this portion, what will happen? You will say, I'll do a plus 1 because this E matches with this E. And thereby this index will go minus 1. And the other one will also go minus 1. But if this guy goes minus 1, it will go to negative because this was the 0th index. It will go to negative. If it goes to negative, it's over. And similarly over here, this will happen. They are matching. So index 2 will go to negative. Index 2 will go to negative. This will become negative. Over here, this becomes negative because they've matched. So when you're comparing, either of index 1 becomes negative or either of index 2 becomes negative. What does negative signify? Let's write. Negative means end of the string. Negative means end of the string. Very simple, guys. If f of 2 means string 0 to 2, negative will mean end of the string. So can I say, if at any moment index 1 is lesser than 0 or index 2 is lesser than 0, I can say it's the end of string. If it's the end of the string, what is the longest length? 0. What's the longest length? 0, guys. So I can say this is 0 and I can easily return. Either this goes negative or this goes negative. You don't have anything to compare. So the returning length will be 0. This is how the recursive code will look like. Now, in order to get more clarity, what I'll do is I'll take this example and try to do a recursion tree so that it gets clear on you, like on a crystal clear method. CED, okay? Where are we? We were here. Okay. What did the first step? What is the first step? 1 plus. Perfect. And we'll call the function. So over here it will be something like 0, 1, 2, 0, 1, 2. The function call will be for f of 2, right? What will be the next function call? Plus 1 on f of 1, 1, which will be AC and CE. F of 1, 1 means AC and CE. So AC is here and E is here. Are they matching? No. So there will be two split calls. Let's do the two split calls. So when I do the two split calls, it will be plus 0 and f of 0, 1 will be one split call and f of 1, 0 will be another split call. Basically, you reduce 1 or you reduce this one. That's what you did, right? That's what you did. You either reduce this or you either reduce this. So a split of 1 of 0 or a split of 1 of 0 will happen. Okay. So what does this signify? 0 of 1. A, C, E, and this signifies AC and C. Perfect. We are standing over here, we are standing over here. We are standing over here and we are standing over here. Okay. So this recursion will be solved at first and then this recursion will be solved at first. You are understanding, right? F of 2, 2 will call f of 1, 1. F of 1, 1 will call this and take the max of this and the max of this. So f of 0, 1, what will happen? A, E are not matching. They are nowhere matching. A and E are nowhere matching. So what will happen? Again, two split calls will happen. If they're not matching, two split calls. And what will be for the split call? It will go to minus 1. One, comma, 1. What will happen to the split call? It'll go to f of 0, 0. F of 0, 0. Understand? 0 is a split, 1 is, so basically you reduce. So what will happen to the split call? It'll go to f of 0, 0. F of 0, 0. Understand? 0 is a split, 1 is, so basically you reduce. So over here, it gets reduced to nothing by CE, and over here it gets reduced to A by C. Why? Because you're moving this guy. So A by C is what it reduces to. Okay? Again, what will this return? Negative. This guy returns 0. A of C, if you go on solving this, what will happen? Again, two split calls. F of minus 1, comma, 1, and f of 0, comma 0. Or rather, this will be actually 0. So f of 0, comma minus 1. Right? So this will also return a 0 because of negative. Because of negative, this will also return 0. So f of 0, 1 called those guys and it got 0 and 0. So this guy actually got a 0. So this guy will return a 0. F of 1, 0, what will happen? Let's analyze why what will happen. C and C matches. So 1 f of both will reduce 0 and minus 1. So both will reduce. 0 will reduce to minus 1, 1 will reduce to 0. Because C is done, C is done. So you move this to here and this is over. So 1 1 plus this, what is this? Negative. So this guy will return 0. So 1 plus 0, this guy's value is 1. This guy's value is 0. So f of 1, 1 called both the guys. One guy gave him 0, the other guy gave him 1. Which one will he take? He will take 1. The max of both the guys. Over here we had a plus 1. So plus 1 and plus 1, f of 2 gives you 2, which is the answer. F of 2 gives you 2, which is the answer. And eventually CD is the string, which is the longest common subsequence. So you got the answer. So you saw the recursion tree working perfectly, and it did give you the answer. Very straightforward in all the comparison of string problems. If they're matching, you just take both of them back. And they're not matching, you take either one string, you shrink one string, or you shrink the other string and try to do a comparison. And if you're able to do this, you can actually solve any problem on string comparisons if you can understand the movement of strings. Fine enough. So what are we doing as of now? We are actually doing recursion, and we know we are applying possibilities, right? So the possibilities, since you're trying out all the recursions, it's going to be 2 to the power n subsequences of this guy, 2 to the power m subsequences of the other guy, because you're trying out subsequences. Like if you carefully observe, you are trying out subsequences AC, you're trying out subsequence. 2 to the power n subsequence of the first string, 2 to the power m subsequence of the other string. So that will be like near about exponential, which is definitely something which we don't want, and we want this to be optimized. We want this to be optimized. And eventually, CD is the string, which is the longest common subsequence. So you got the answer. Take both of them back.
So this is the first approach we have followed, the recursion approach. The base condition is that both the indexes should be greater than -1, greater than equal to 0. Then the procedure is going to run, and if it is not, then we will return 0, because we didn't find any subsequences that matches the string. And there is also there is two conditions for the execution. If string 1 of and index of that string 1 is equals to index of string 2, then we go to the next string. That's a basic next one, and we will add 1, because we have find one character that equals to the string of second string. And also if I didn't find anything common or same, then I will reduce or decrease the index of either one of them, either of string 1 over the second one. Okay, cool. Index 1 and index 2 minus 1, that will be the procedure. And now I'm gonna look what should I done for because we have the time complexity is 2 to the power n, because we have finding all the procedure, not the procedure, all the subsequences that the string can form. Then this will be a very time taking, so we have to reduce the time. And now we're gonna solve by using memoization, tabulation, and space optimization.
And they're not matching, you take either one string, you shrink one string, or you shrink the other string and try to, right? So the possibilities, since you're trying out if you carefully observe, you are trying out subsequences, AC, you're trying out subsequence. To the power n subsequences of the other guy, because you're trying out subsequences. If you carefully observe, you are trying out subsequences, AC, you're trying out subsequence. To the power n subsequence of the first string, to the power m subsequence of the other string. So that will be like near about exponential, which is definitely something which we don't want, and we want this to be optimized. We want this to be optimized, correct? And how do you optimize this? You have to see if there are overlapping subproblems, because if there are overlapping subproblems, we can apply memoization. I've already told you this in all the previous lectures. We can apply memoization. Let's see if there are overlapping subproblems in this particular problem. F of 2 was there, F of 1 was there, F of 0 was there, F of 1 was there, F of 0 was there, F of minus 1. That's a very small set to see, but if you take bigger examples, you will see like these guys getting repeated somewhere over here, or similarly, you can see over here there's one state repeated. F of 0 minus 1 is repeated here also. You see both the states are repeated, and that's a base case. That's okay, but you will see if you take a bigger example, you will see states being repeated. You can take a bigger set of string, and you'll see that the states are repeated. So what 0 to j. In this, they want the length. So if someone again comes up and asks you the same question, why do you want to pre-compute? Why do you want to recompute? Thereby, we can easily apply memoization. What is the technique to apply memoization? Look out at the changing parameters. One is I, the other is j. What is about I? It's n. What's about j? It's m. Thereby, you can say n cross m is what I will be requiring TP. So you can easily just declare a TP of n cross m, initialize everything to as -1, and you can just go back and add these lines over here. This is the return state TP of n cross m, initialize everything to as -1, and you can just go back and add these lines over here. This is the return statement, right? So over here you can say, okay, fine, I'll write -1, and you can just go back and add these lines over here. This is the return statement, right? So over here you can say, okay, fine, I'll write dp of ij equal to, this is the return statement. You'll say, okay, fine, I'll write over here, and whenever it enters, a very simple line of dp of ij is not equal to -1, and you return dp of ij. That's how you easily do it. That's what the function resembles. So it's time to check out the code. So we're given the string s and the string t. So you can just give s dot size, right? And you can just give m.
I think I have seen that mostly of the question that give TLE while solving by using recursion, but they can be solved using the memoization. But the compiler does not give the TLE. If you run any program or on any TLE, then okay, so I think the tabulation solution is required when you are in interview, when the interview asking you the question, then you can give the solution about the interview. But if you can't think of the tabulation solution while solving the problem on compiler any or the IDE, I think you can be this solution will be enough if it is not giving the runtime error. I think it, if it is running, then the golden rule of coding, if it doesn't, if it is running, then don't change it, I guess.
Equal to t dot. And right here you can say return f of, you can n-1, that is what we take, s and t. Perfect. Let's figure out the function that we generally write, int f, int I, int j. Make sure you pass the string by reference, because every time if you create a new string, it might give you TLE. This is what you wrote, this is what you wrote. Return 0. If they're matching, which is s of I equal to t of j, then you can return 1 plus f of I minus 1, j minus 1, and s and a t. And they're not matching, you return the max of either both of them, and I minus 1 j, s and t, or you just go 1, which is s comma t. That's how the brute force will look, and obviously you need to optimize this by applying memoization. So just apply memoization over here, which is dp of n cross vector of int and m cross -1. Please make sure you pass the dp over here. And once you pass the dp, right over here, you get the vector of vector int and dp. And you just pass on the dp over here. You can just pass on the dp over here. You can also pass on the dp over here. Perfect. And what I can say is, okay, fine. The next thing I'll do is memorize. So let's quickly memorize this. And as the last thing, you will just say, please check if the state has been visited previously. If this has been visited previously, kindly return it. And that's what the code will look like. Hopefully it should run. Okay, that's some issue. Okay, dp was not declared in the scope. Okay, looks like vector has not been declared. So what it says is you have to actually use hash include bits std c++ dot h, because vector has not been defined. So you easily define this, and after this I think it should be running fine. Fine, it runs. Now we're getting a 100 score. And that's how the memoization technique will be. Now the next step will be tabulation, because you have to optimize the auxiliary stack space. And the time complexity in order to solve this by memoization was we go of n cross m, which we took in order to solve this using memoization. And the space complexity we took was n cross m for the states storage in dp, and we go of n plus m in auxiliary stack space. Right. Now you might ask, sorry, why n plus m? I'll give you an example A, B, and C, D. I'll ask you to draw the recursion tree for LCS. Remember, in match it was 1 plus, and in unmatch you moved in two directions. So this is unmatched, so you move in two directions, which is A by CD, and the other one is AB by C. Very obvious because you either eliminate this or you either eliminate this. Again, over here, you again move in two directions because they do not match. So you either eliminate A, which makes it CD, or you either eliminate D, which makes it A by C. Over here, again, in two directions, you either eliminate A or you either eliminate C. So if you carefully observe, 1 step, 2 step, 3 step, 4. So at max the depth is 4. Length 2 plus length 2. Because what we did was, we deleted B, we deleted D, we deleted C. So alternative deletions. If you do alternative deletions, there can be n deletions from string S1, there can be m deletions from string S2. Thereby the auxiliary stack space will go as n plus m. But obviously, as always, I'm not a big fan of n plus m. So I'll have to omit this. In order to omit this, I have to write the tabulation iterative bottom-up approach. Whatever you can call it. Okay. So bottom-up. Rules I've already told you. What are the rules? Copy the base case. I've already told you the rules. Copy the base case. Second, write down the changing parameters in the opposite fashion. Perfect. Third, copy the recurrence. If you can follow these methods, I can we deleted C. So alternative deletions. With alternative deletions, there can be n deletions from string S1, there can be m deletions from string S2. Thereby the auxiliary stack space will go as n plus m. But obviously, as always, I'm not a big fan of n plus m. So I'll have to omit this. In order to omit this, I have to write the tabulation iterative bottom-up approach. Whatever you can call it. Okay. So bottom-up. The rules I've already told you. What are the rules? Copy the base case. I've already told you the rules. Copy the base case. Second, write down the changing parameters in the opposite fashion. Perfect. Third, copy the recurrence. If you can follow these methods, I can guarantee that you can write any of the tabulations of bottom of any of the questions. But copy the base case is a bit tricky over here. Why? Because if you remember the code was I come bottom of any of the
Yeah,
question.
tricky. It's tricky.
But copy the base case is a bit tricky over here. Why? Because if you remember the code was I comma j, and it was something like I lesser than 0 or j lesser than 0, and you return 0. So over here, this was the base case, right? If you remember, this was the base case. And in the base case, I can be negative. And usually we did see, in the recursion tree. If you remember the recursion tree, I'll just take you to the recursion tree that we did. In the recursion tree, the negative was minus 1, minus 1, minus 1. So we stopped at minus 1. So we can't write cases for minus 1 in base cases. Can you write for minus 1? Because how do you write dp of minus 1? That's not possible. That's not possible. So what we do is we do a shifting of index. Very simple. We do a shifting of index. In order to write tabulation. You can still write tabulation using this, but I want you to teach. That's not.
What
So
we are doing?
we can't write cases for minus 1 in base cases. Can you write for minus 1? Because how do you write dp of minus 1? That's not possible. That's not possible. So what we do is we do a shifting of index. Very simple.
Okay.
Minus 1. Because how do you write dp of minus 1? That's not possible. That's not possible. So what we do is we do a shifting of index. Very simple. We do a shifting of index. In order to write tabulation. You can still write tabulation using this, but I want you to teach this shifting of index. In order to write tabulation, like without even shifting of index, I can still write tabulation, but that will be a bit tricky, so I'll not go that direction. Shifting of index. So as of now, there was index 0, 1, 2, like minus 1 was the negative index 3, till on n minus 1. And we were calling these indexes, like how did the function start? The function call started from n minus 1 and n minus 1. And n minus 1 represented this index. F of 0 represents this index. F of 1 represents this index. Can I do a shifting? Can I do a right shift of the index? And I say, I will call n f of 0 represents this index. F of 1 represents this index. Can I do a shifting? Can I do a right shift of the index? And I say, I will call n comma n. I will call n comma n. Yes, I'll call this. But over here I'll say, hey listen, n means n minus 1. Okay. F of 1 means 0. And f of 0 means negative. I shifted the index, one right. N means n minus 1. 1 means 0. 0 means minus 1. I shifted it one right. Okay, makes sense. So we're shifting it one right. So can I say f of ij? We've shifted ij, like initially I is n and j. Initially I is n and j is m. You've shifted it. N is actually n minus 1. 1 is actually 0. So can I say, that means every I that you're giving should be treated as I minus 1. And every j that you're giving should be treated as j minus 1. Because that is the meaning. Because as of now you're sending I and j in terms of one shifted index. Okay, that makes sense. So shifted it. 0 means minus 1. If I shift
Okay, to solve this problem, the base condition we have to check by shifting the conditions, shifting the indexes by right side one, because we can't go to the minus 1, so we will check for the 0. I think if we find anywhere the 0, then we will stop, and all the indexes treat is as plus 1 by its original index. 0, 1, 2, 3 up to n minus 1, and f and m n treat is as n minus 1, and m treat is as the m minus 1. Okay. And minus 1 treat is as f of 0, and 0 to 8 is as f of 1. Someone's here. Wait.
shifted the index one right. N means n minus 1 means 0, 0 means minus 1. I shifted it one right. Okay, makes sense. So we're shifting it one right. If so, can I say f of ij? If you've shifted ij, like initially I is n and j, initially I is n and j is m, you've shifted it. N is actually n minus 1. 1 is actually 0. So can I say that means every I that you're giving should be treated as I minus 1, and every G that you're giving should be treated as J minus 1, because that is the meaning. Because as of now, you're sending I and J in terms of one shifted index. Okay, does make sense. Does make sense. So can I say, instead of greater than 0, can I write this as I equal to 0? Because this signified I equal to minus 1. But since I've shifted it, can I write I equal to 0? Yes. And can I write, instead of this J equal to 0? I can. The base case has been changed. If I take it back to the code, over here, instead of n minus 1, I can write n, m minus 1, I can write m, and over here I can write equal to, and in the G also, I can write equal to, but what the other changes? Everything stays same. States being called same. You're doing a string comparison, but I means I minus 1. J means J minus 1. Changed. And now if I run this code, does this run same? It will. Why will it? Because you've just shifted it. Okay, it's giving runtime error. Why does it give runtime error? Because the DP that you declared is of nm, and you're now using the states of nm. So just make sure you declare a DP of extra size m plus 1. And now you've done a shift. And now it's same. Can write, take it back to the code. Over here, instead of n minus 1, I can write n, m minus 1, I can write m, and over here I can write equal to, and in the G also, I can write equal to, but what the other changes? Everything stays same. Been changed. If I take it back to the code, over here, instead of n minus 1, I can write n, m minus 1, I can write m, and over here I can write equal to, and in the G also, I can write equal to, but what the other changes? Everything stays same. States being called same. You're doing a string comparison, but I means I minus 1. J means J minus 1. Changed. And now if I run this code, does this run same? It will. Why will it? Because you've just shifted it. Okay, it's giving runtime error. Why does it give runtime error? Because the DP that you declared is of nm, and you're now using the states of nm. So just make sure you declare a DP of extra size m plus 1. And now you've done a shifting of index one right, and it does work fine. So okay, so the base case has been, now the base case has changed. What's the base case now? The base case is now very simple. It states if I is equal to 0 or j is equal to 0, we are returning 0. How can I write this in simple layman terms? Okay, what does I equal to 0 means? It means any DP of 0, and this guy can be anything because this is j. J can be anything. And what does this mean? I can be anything, but this guy has to be 0, right? And what can be the possible values of j? Anything from 0 to m minus 1. What can be the possible values of anything, but this guy has to be of 0? How can I write this in simple layman terms? Okay, what does I equal to 0 means? It means any DP of 0, and this guy can be anything because this is j. J can be anything. And what does this mean? I can be anything, but this guy has to be 0, right? And what can be the possible values of j? Anything from 0 to m minus 1. What can be the possible values of I? Anything from 0 to m minus 1. Loop it. Right? And what can be the possible values of j? Anything from 0 to m minus 1. What can be the possible values of I? But this guy has to be 0, right? And what can be the possible values of j? Anything from 0 to m minus 1. What can be the possible values of I? Anything from 0 to m minus 1. Loop it. The base case are very simple. J can be anything from 0 to m minus 1, and dp of 0 and j will be 0. This is for this one. And for this one is this. I can be anything from 0 to n minus 1, and dp of I comma 0 is equal to 0. Base case written by shifting right shifting indexes by 1. Base case has been written. Perfect. Next, write down both these guys in opposite fashion. Okay. So the moment I shifted it, the recursion was taking I from n to 0 and j from m to 0. Top down, top down. These are the base cases. What is tabulation? Bottom up. You go up. So 1 to n. Why not 0 to n? Because 0 is the base case which has already been written. So 1 to n. What about j? Opposite. Done. Next, copy the records. What are you waiting for? Just go back and copy the records, and you'll be able to easily write the tabulation format of LCS easily. So what I'll do is I'll go back and try to write the tabulation format. Okay, so we have this guy. That's perfect. Let's just comment this and try to write this. So if you remember, it was I equal to 0, or rather, yeah, j equal to 0 was the first one. J equal to 0 and j less than m. But then now it will go j this dp of 0 and j is 0. Perfect. And similarly, I can go as 0 till n. I can go as dp of I and 0 as 0. Perfect. And similarly, for loops can go as I equal to 1, I less than equal to 1, I plus plus. Similarly, the j loop can also go in a similar fashion of I and j equal to 1, j less than equal to m, j plus plus. And you can just copy paste. Yes, just make sure you copy paste the same thing. Just instead of written, just remove written. Yes, just remove written. And just copy the same thing, exactly same thing. And over here, just return dp of n and m. And remove this. Now what you can do is you can also remove this portion. And instead of f, just make sure you write dp of I minus 1, j. Perfect. And over here you can write max of dp of I minus 1, j. And again, you can just remove this portion. And it's a comma of dp of I and j minus 1. And again, please make sure you remove this. Yeah, that's what it will be. So if I now try to run this, probably should run. If I've not done syntax mistakes, again, the hash include missing. Again, it's giving us a wrong answer. This probably should run. If I've not done syntax mistakes, again, the hash include missing. Again, it's giving us a wrong answer. Why is that? So you check out why is this giving us a wrong answer, and then we'll get started. So why did this give us a wrong answer? Because in the recursion, if executed, it went back from there. Over here, you have to just make sure you write an else. Okay, just make sure you write an else because it will not return. In recursion, this line was not executed. In for loops, it will be so. Just make sure either it is matching or not matching. It is running fine. Now you can just go across and submit. So can we do space optimizations? Yes. I've always told you if there is a scope of I minus 1, which means previous row. I minus 1, which means previous row. You can always, I repeat, you can always, I've always told you if there is a scope of I minus 1, which means previous row. I minus 1, which means previous row. You can always, I repeat, you can always space optimize the same portion. So what you do is, instead of this, just make sure you have a previous of m plus 1 comma 0 and a curve of m plus 1 comma 0. Perfect. And over here, this will go as, this is the 0th guy. So what I'm basically saying is, okay, for any 0, what will happen? So this is dp of 0, right? So you get the previous, and will this be there? Will the column be there? No, there's no need of column. So you just format this. For the first row, everyone is 0, right? So that's what we've done. Over here, just make sure instead of dp of I minus 1, that's previous. Over here, just make sure instead of dp of I minus 1, it's previous. Over here, this is fine. Instead of dp, it will be curve. dp of I will be curve. Just make sure it's curve. And over here, instead of dp of I, this will be curve. Instead of dp of I, this will be curve. Perfect. And just right after this, you will curve equal previous. And over here, just return the previous guy. Or curve, whatever you wish to. This is fine. Yeah, this should look fine. So now you can try submitting this, and you will see that this is also not running fine. Why? I forgot to have a colon. Okay, so if I give a colon, just previous column, previous color concept, and okay. So the issue was previous equal to column here, not current equal to previous. My bad. Okay, so if I just give it a submit, should be running fine now. Yeah, should run. If I give it a submit, this will definitely run. So guys, I hope you've understood how I took a memorization solution. And since we were having problem with tabulation, I shifted it by right so that we do not have negative integers or negative indexes in these cases. And after that, I just simply converted that into a tabulated. Once I converted that into tabulation, I shifted it by right so that we do not have negative integers or negative indexes in these cases. And after that, I just simply converted that into a tabulated. Once I converted that into tabulated, space optimization is an extension of whatever I've taught in the previous DP lectures. So if you haven't seen the previous DP lectures, it's your, you should definitely go and watch it because you're missing on space optimization, which is a very, very important fact. So guys, I was able to make you understand LCS. Just in case I was, please make sure you like this video. If you're new to this channel, please do consider subscribing, and yeah, to continue your relation, please make sure I understood in the comment section. And with this, let's wrap up this video and meet you in the next one. Bye, take care. we will be given a couple of strings, and we did learn how to print the length of the longest common subsequence. Like the length over here is 3. So we did learn how to print the length of the longest common subsequence, and we got it as 3. Now, what if I change the question? Yeah, the question might ask you, okay, it's fine, you're giving me the length. What if I want the string? Yes, what if I want the string? Like over here, the longest common subsequence is nothing but, if I carefully see, I will have a B, I will have a B, I will have a D, I'll have a D, I'll have a E. So I can say the string is BDE. This is the LCS. What if someone comes up and says, hey, can you please print me the LCS? Can you do this? You can do it via brute force. But can you do it in an optimized way? I think we can. So in order to do this, what I will do is I'll go back to the summation that we did. So if you remember well enough, we did a summation. No, not this one. The tabulation summation. Let's copy paste the tabulation summation. So this is the summation that we did. Okay. Now let's take couple. Let's take the example A B C D E and B D G E K. Okay. And let's do one thing. Let's simply print the DP array. Okay. Let's 0 j less than or equal to m and j plus plus. I can be like C out of DP of I j. Okay. And this is something we can go as C out of n. Perfect. So let's quickly print the DP array and let's see what is the DP array coming across. So this is what the DP array looks like, and this is the answer 3. So let's write this in our iPad, and then I'll be explaining you. Okay, so this is how the DP array looks like. We did print it, and we know this is the I, because these are the row numbers, and the column numbers go over here. And if you remember, while doing the tabulation, we converted this into one-based indexing. You must be remembering. That's why if I write down the indexes, this is the 0th index, first index, second index, third index, fourth index, fifth index. This is 0, this is the first, this is the second, this is the third, this is the fourth, this is the fifth. And if you take the string S1 equal to A, B, C, D, E, and S2 equal to B, D, G, E, K. So this is a string of length 5, but if I write down the indexes 0, 1, 2, 3, 4. But the answer is stored over here. Like if you carefully see, the answer is stored over here in a 5 and a 5. Okay, so basically I can say A, B, C, D, E. This is the ith guy, and then you can say B, D, like, or you can just write it over here B, D, G, E, K, because you're doing one-based indexing. So this is why only this portion of the DP matters, and these guys do not have any value. Okay, so what does this tree signify? Where is the stored? At 5 and 5. Let's write the meaning of DP of 5 and 5. What is the string? A, B, C, D, E, B, D, B, D, G, E, K. Length 5 means entire string. Means entire string. A, B, C, D, E. Length 5 means entire string. So B, D, G, E, K. In both the strings, what's the longest length? 3. That is what is stored here. Okay, so in order to understand this, let's take this 2. Where is this stored? Stored at the index 4 and stored at the index 2. So at 4 and 2, this is stored. So let's write dp of 4, 2. So it's saying take a length of 4 string. That means A, B, C, D. A, B, C, D. Take a length 2 string, which means BD. Let's say BD. So in this, what is the length of the LCS? That's 2. If you carefully observe, we have a B, we have a D, and we have DD. The length of the longest common subsequence is 2. Thereby, the DP array stores 2 over here. Similarly, if I say, why is the 1 stored over here? Because in this BD, why is the 1 stored over here? Because in this BDGE and in this ABC, there's only one thing common, that's B. Thereby, 1 is stored over here. That's the meaning of DPs. Okay, so how do you compute the answer? That's a big question. So if I ask you, how's the tabulation looking? So if I ask you, what are the formulas that you wrote? You wrote a simple formula, dp of ij is equal to 1 plus dp of I minus 1 and j minus 1. And this did happen when these guys were equal. Like s of I minus 1 was equal to like s of 2, j minus 1. This is when you wrote this. Remember, this is the first condition that you wrote. Or else what did you write? Or else you wrote, very simple condition, dp of ij was max of dp of I minus 1j, that is previous row, same column, and dp of I comma j minus 1, same row, previous column. This is what you wrote. Either the upper one or the down. Either this one or either this one is what you wrote. So if I ask you a very, very straightforward question. Over here we have a 3, right? And we have a E and we have a K. Do the match. I say no. So basically when the tabulation will go across, like I'll show you in the code, basically what happens is there's an I and there's a J. So they will be running. So whenever they will be at this stage, from where does this 3 come? Whenever you're at this portion and you're trying to fill up dp of 5 and 5, dp of 5 and 5, when you're trying to fill this up, does K and D match? No. K and D do not match. So if they do not match, where does this 3 coming from? This line. Either the maximum of the previous row column or the previous guy. So basically, either the maximum of previous row, this is I comma j minus, this is I minus 1 comma j, and this is I comma j minus 1. Either of these guys maximum comes and gets stored over here. Thereby, this 3 did come from here 3. So what you do is you'll say, okay, fine. We came from here, so you will go over here. You will straightforward go over there, right? You start from this last guy, which is n cross m, and then you start moving the pointer. So right over here, you're here. Okay, now this is an E, this is an E, which means they are a match. They are a match. And if they are a match, where will this 3 coming from? Where will this 3 coming from? This 3 will come from 1 plus something on I minus 1 and j minus 1. What is I minus 1 and j minus 1? That's nothing but this guy. I minus 1 and j minus 1 is nothing but this guy. So basically what you did was, you took the value from here, you added a plus 1, and you wrote it over here. So now what will happen is, you will go over here. But remember this, before going over here, since this E matches to your E, you just store that as an answer. You store that as an answer. So you know that the length was 3 of the LCS. So remember, create an array or a string of length 3 and store E in the last index. Perfect. Now you're at 2. Does this D and does this D and does this D match? The answer to that is no. They do not match. So again, where will this 2 come from? The max of this or the max of this? So you go to the max. Perfect. Remember, whenever you go to the max, there is no need of taking any string. Perfect. Here's a D. Here's a D. Here's a D. They match. So if they match, where will this 2 come in from? This 1 plus 2. Perfect. Take this 1. So this came in from here. So before moving to this 1, a D is common. You just fill that D in. Perfect. Now you're at 1. Does the C and does this B match? No. So if they do not match, where will this 1 come from? Either the max of this or either the max of this. So what you do is you go to the max. So just go to the max. Perfect. Now, you're at here. This B and this B matches. If this B and this B matches, what can I say? They are matching. Thereby I can take this. And if they're matching, where will this 1 come from? From the diagonal, because it's I minus 1. Thereby you'll go here. Remember this. This was the string BDGEK. You exhausted. The j is now standing at the 0th index. You exhausted. There is no more length of the second string remaining, so it's over. No need to do anything. Remember, if the string gets exhausted, either of this string or either of this string, you will stop. If the string gets exhausted at any moment, you're right away going to stop without traveling. So what did you see? You moved, and whenever there was a diagonal movement, you took the strings and you put that into the length 3 string that you were looking for, right? So guys, in order to write the code, it's going to be super simple and super straightforward. I know one thing for sure. I will initially have my pointers at n and j equal to m. That's for sure, because initially we will be starting over here, and then we will decide whether we move to the max or whether we move to the diagonal, right? So I know one thing. I will keep on doing till it gets exhausted. So if this is greater than 0, that means I have some length of string R, first string, some length of string 2. So let's go on doing. Now, what was this thing that we were checking? We were like, okay, we are at I and j. Let's go back to the table. Initially, what did you check? You checked, is this E equivalent to this K? So just go and check. Remember, 0 is indexing. So you'll be like, okay, if S1 of I minus 1 is not, is rather equal to S2 of j minus 1, that means they're equal. They're equal. So as of now, they're not equal. So let's not think on this. Let's not think on this condition because they're not equal. Let's try the else condition. What if they're not equal? What if they're not equal? Then we have to figure out where did this 3 come in from? Because we always take max of the previous row or the previous column. So let's see where this 3 comes in from. Either it will come from here or either it will come from here. Remember one thing, it might come from any one of the places. In that case, you can move anywhere. Remember, if there's a 3 over here and there's a 3 over here, then you can move here or you can move here. It's okay. That means it might have multiple answers, and you cannot print multiple answers using a TP table. Then you have to apply normal brute force. So if there's a 3, both of the places, you can move anywhere. So you'll be like, okay, I know one thing for sure. It either dp of I minus 1j, that's the previous row, would be greater than the previous column, or it will be the other way. Because I know one thing for sure, this guy is either greater than this, or this guy is either greater than this. Like anyone will be greater because I take max of both. And whoever is the max, like over here 3 was the max, so I move. So how's this movement? If this guy is greater, I move towards him. If this guy is greater, I move towards him. So let's see. I'm saying this guy's greater, so I move towards I minus 1. So I'll be like, I please move towards I minus 1, or J move towards J minus 1. Like in this case, J will happen. In our case, J would have moved, right? So in this way, you can move the I pointers and the J pointers, correct? In the next I pointers or J pointers. In the next step, you are over here. You saw this guy matching with this guy. Thereby, the matching case comes in. And whenever there's a matching case, remember this. Whenever there's a matching case, you have to store in the string. So you know the answer was the length of the LCS was very simple. It was dp of n comma m, right? So probably you can create a string. You can create a string s equal to, probably you can as of now keep it empty, and then you know the answer is I equal to 0 till length. So s plus equal to, probably you can just assign some dummy dollar values, assign a dummy array, dummy string of dollar assigned. Okay, and probably what you can do is you can keep an index equal to length minus 1, right? And if this is the case, then you can say, okay, in our string or in our LCS string, in index, I will store s1 of I minus 1, and the next moment I'll shift the index. So that, why am I doing this? So that, remember, whenever this E and this E match, I'll store E where there was the index, then I'll move the index to the previous, so that for the next step it gets stored. Perfect. We have stored the index and we have moved the index back. What about I? I will move one step as well as J will move one step. Very important. Both of them will move. Why? Because they have to move to the diagonal. So thereby they'll move to I minus 1 and J minus 1. So this is the entire set of code. If you write, you will be able to print the answer. So if you see in the code as well, I've written the exact same thing, taken the length, assigned the answer and the index, it's exactly the same thing. And if I take both the strings and if I just run it, you will see that the string is getting printed. So that's how you can print the LCS. So the time complexity will be definitely n cross m. You have to use the tabulated, like you have to use the entire 2D array so that you can backtrack, and you can simply backtrack. And what will be the
Okay, so now I'm gonna solve 5 and 6 longest palindromic subsequence, and I have now grasped what I have to do when there is a strings present and we want subsequences or common longest substring like that. So let's think of a solution of this problem, longest palindromic subsequence, and let's read it. Given a string S, find the longest palindromic subsequences length in S. Okay, so palindromic subsequences means that have, if you read from the both side, it should be same. A sequence is sentence that as sequence that can be derived from another sequence by reading some of the normal. Okay. Example BBAB, BBBAB. So longest palindromic subsequence we can get from this. Okay, we can get BB if we, okay, subsequence means we can reduce the A. We don't have to take the all the characters that are in adjacent to each other. We can get any subsequence, like the subsequence like B B B A B and BBA BBBA. Then we can take B these 4 B's. If you read from both the sides, it will be same. Okay, and now in this you have C B B D, and if you take BB, then this will be the palindrome, and for it has to be palindrome. Like if you have problem like A B A B A. Now what can I get from that? If you read from the both direction, it will be the same, then it is a palindromic, then we don't have to check anything. And if we take also here a B, then it is not a palindrome if we all take all the conditions, all the characters. But if we take these 5 characters, this will be the same. And how we gonna get? Okay, we are gonna store the values of the, consider only of a lowercase English letter. Okay, let's think of a recursion solution. The string length is n. Okay, okay, so now we have the string size, and we go to check the conditions if it's palindrome or not. And how can I do that? By let's return the function first, and we will return the size, the string, Okay, if I check uh, okay, so if I take what, if I take two pointers, one is starting from the one is at the starting and one is at the end, and I will compare, oh, whenever I found the same character. Okay, so I found the character, then what I do, what should I do? And now check for the, if I found the letter same uh, at the starting, now I go to the next letter and then check if it is correct. If it has the same letter, then it will count in, it will count in as a, okay. And if it doesn't, then what should I do? uh, I'll move for in the next letter. For example, I'm at these position, like functions. I've called the function, and which is at the starting and the ending of these, one at index 0 and one at index n minus 1. First I call if the check for if the condition these are same, the a and b, if both are different, these are different, then it's not true. But if okay, so if it doesn't true, then I can do uh, okay, I can move for in both the direction. Like if it is true, then what I can do, I can move in one and n and for the n minus 1, let's take 1 2 3 0 1 2 3 4 5. Here is 5, and now I am at the position 1, and here I can move to position 4 because we have checked these two. No, but these are not true, then I can't move in here. I can move in this direction, like okay, I haven't found, then I will move, I can move in direction like uh, move one index from starting, or I can move one index from the last, from the end. Let's try one by going to the from the starting one, and this will remain the same 5. Now we will check if it is true. We have b at the index 1 and the index b, or b also at index 5, then it is true. Then what will it return? It will return, okay, it will return addition to 2, return 2 plus, and moving plus 2, and we will move to the next 2 and 4, and it's similar to like that. If in this direction we move at 0 and 4, and if we check at the index 0 and 4, at 0 we have a, and at the 4 index we also have a, then they are both same, then the condition satisfy, and then condition satisfies, then we will return similar to that 2 plus, and reduce. Okay, we will increase the 1 and reduce the last counter. Now moving in this direction, okay, now moving in direction at 2 and 4, 2, this is 2, and this is 4, 2 and 4 also same. Then we can return 2 plus 2, 4, and we will reduce these 3 and 3. Okay, okay, now if we don't have, okay, now we got the position, and now we will check this position. Now we are at the in the middle, and we have B for the both the condition, and it will also should check, and we are at the same position, then it will be same, but this will be the answer we will getting from this problem. 1 2 3 4 5, but we have to get the 5. Okay, now okay, now we will getting 4, but we also have to include this letter, because this is also a palindromic letter. Okay, so I think this is the base condition. Whenever we found at the last and first, last counter and from the first counter is equal at the same position, then we will turn 1, and it will be added to the let's try to type this. Let's see. Let's take int start. Wait, I have to give here int okay, left is equal to 0, and right is equals to as a size, and we'll start from 0 to n minus 1, and I can give this is also left, and okay. And whenever when we will stop, and we will stop the condition when if last less than equals to r, then we will return 1. Okay. And we also wants to, I have to also tackle whenever the string is not any palindrome, and we are getting I think every string that has the value uh, one letter is always a palindrome. I think like yeah, if all the letters are different but one character should be the same, because we can add the position similar to that. Okay. Now for the condition int no if our string which is starting from L is equals to string of right, if it is equal, then what I can do,
भाई कैश ले ले भैया तेरे पास है मिलना रे ना
okay, where are we? Yeah, we will checking the left and right. If it is uh, correct, then we will call the function, and we will increase the value of 1 and minus 1, and also we will give the string. Yeah, and okay, written 2. Yes, I think. And if it is not true, then I can return the function can go from do I have to take the maximum of? I think so. L minus 1 r remains same string. Okay, I haven't called the function. This time L remains same and R is decreased from the end, and the string is same. And is this enough? Is this a solution? Is the 2-line solution? No, I'm getting the simple one, and here I'm also getting 1. Why would I getting 1 if not the if condition? Moving from the if like I'm returning 1, find the longest. Okay, here we know, I know that I have to return the longest palindromic subsequence, and it will store. What will it store? This will checking the condition for that. I think it doesn't have to store anything. I just have to return this and change the value. I will get the output whenever this condition satisfies, like if and else. Just if it is not true, then return. Just move. I have to move in both the direction. And how can I do that? I think I have to give the answer 0, and here I should answer is equals to answer plus 1, and if it is true, then it will store increase the 1, and here I can also give the answer, and now I can return if this condition not satisfy, then the how can I move to the next letter if this condition not satisfy? If else, mm, function L plus 1 R S function LCM R minus 1 S and return answer. Now I'm getting 0. This condition not working properly. Okay, if the condition satisfies it's true, then we will return 2 and move to then move from one side from the start, one from the end. Okay, if it is not true, then if it is not true, then what I can return? I will return 0 0 and 0 work. I don't think so. If I return 0, what that would tell us? Is something on the description should be marked as hard? Why? Got that. Let's take a hint. Oh, I'm very close. Just a base condition mistake. Okay, I think I have written okay 0. Yes, I have written 1. Ask yourself, when should a recursion stop? What should we return when less than equals to and equals to 1? Should we return 0? Okay, for longest parallel solution, the correct base cases are if it is less than 0 and if it 1 single critical random, right? Okay, there's also a small in 3. Okay, I have implemented the solution correctly, but just I have to define that separately. If it is, then I should return 0, and if L equal to R, then you will return 1. Is this correct? Okay, we don't have to return the answer 0. We also don't have to return here answer, and here also. Just return the else condition not needed. Not the answer, we have to return answer. We will return the return the maximum value from this. Again 0. For almost average valid condition, you are immediately returning okay. L less than equals to less than R. Yeah, this is the condition. This is the satisfied condition. This will be like that. And whenever the starting condition or starting counter is becomes greater than the uh, return counter, then we will return okay. Now this is satisfied. And now what I can do, I should add the memorization vector dp, and size will be the R plus 1, I guess, and size will be the R plus 1 or just R. I guess R is good. I can work vector, and now if dp of L and R is doesn't equals to -1, then I can return the value of that dp, and L to R, and every time we have dp L and here I can also give I have not initialized it here. Vector ampersand dp, pass dp here also, and here as well. Now let's check, should be fine. SP, it's dp. Should be fine. Yeah, it's working. What is this condition? Okay, this for the it's taking less time in memorization than the tabulation. Let's try to convert into tabulation. Okay, I think the base condition will be is what can be the base conditions? The base condition could be okay. Okay, the base condition like if L, the base condition would be same like in this. If L less than R, okay, I think for every dp of let's give it a 0, dp of I comma 0, which what is this? This is the condition. Nope, I think it will be more trickier than this condition. Like, what are we solving? Like, this is our dp, and what can I return here? For the base condition I less than I greater than j, we were starting from the I is here, j is here, and every time I becomes the greater than z, every time j becomes, then what would I return? 0. So do I have to run a two loops? I think, and if I return by, if I fill the values of dp 0 by using the two loops, then it will be the same as the previous solution we have solved by memorization, because it's also taking time m cross n, and it also, but okay, it takes the time m cross n, but it that solution taking this m cross n size more. Okay, so I can return every time I becomes greater than is the dp will be 0. dp value of that position is 0. Okay, that will not count in that will be not count in answer. Okay, so and for the condition whenever we found. Okay, so okay, in that loop I can also write if I found the condition which is equals to uh, I and j, means this is one condition in that loop, and second condition is I equals to j, then we give the value dp at that position is 1, and all the condition are all the condition will be same, these two. I think this will work if I think carefully. Let's check one time. What is the solution? Size string, we have one string, we have reversed this string. What? Okay, initialize the vector with the extra size, and starting from the, and if we found there is no base condition, that's a basic for loop solution. I think you have reversed the string, and now you're comparing one by one with all these numbers. If it is correct, then you are adding, but this you have used the tp. I think this will work. And what is the solution? Okay, god damn it. I think most of the solutions like that in the dp. Let's check for one how solved in tabulation approach. We are given a string as and need to find the okay. What he have done? What is the question? Okay, parent sequence. Two strings functions to calculate the length of the longest palindromic subsequence. Okay, we don't. Okay, the second string is the reverse of, I think. that is the string. Create an instance of solution class, print and okay, here we have any problem here. Okay, first function. Okay, here he have reversed the string and then pass the string, and then we have checked. Okay, all the condition are same. And what is this condition? Initialize first row and first column to 0. Okay, these are condition for when you are shifting the shifting case, because you are not passing here the next values. Okay, here size, here you have the greater size, here greater than size, -1 doesn't matter. dp give the value for both in the starting position, they are the bound less than the these are the condition where the -1, and here we have checked the condition for that. Just have to reverse the condition. That's the tabulation approach. Should I do it? Why not? And let's do it here. Don't need to give the next. The size just n. Doesn't it? What? If both these strings are same, then why would we declare the different size? Because we have just the reversed the string for the reading, because I think the size is that. Now we initialize the string s and t, and this string will be reverse s dot begin to s dot end. Now we have this string, reverse string in t, and here we have size n+1. Also we have size here n+1, and 0 matters. I don't think so. Let's go here. Okay, just give the value to all the 0. Put the value. Now for the column part, di equal to 0, less than mn, less than in equals to n, I guess, and I plus plus. Okay, because we have initialized the dp of the size n plus 1, then we have to give the value to all the indexes. That is also 0. Now run 2 loops for di, and size will be less than starting from the 1, less than equals to n, I plus plus, again 1 loop, j starting from the 1, j less than equals to size n and j plus plus. And what I can do, these two copy paste and just remove these. Now what I have here, what I'm doing right it because I have to yes, I just have to check for the condition. If s and t, and s will be I and we can give t a j and dp size is ij, and here we have initialize from the we have to check for the -1 because we have shifted for the from the 1, and now dp will be dp here I -1 and j -1 moving forward, and else dp ij is max of dp, and one time we will increase the dp size of 1 I -1 and one time I remain same and j -1, and in last I should return the last because of the bottom up approach, and the answer will be stored at the last index of dp, and then what that will be the last the size of n comma n. No, what the t string t a reverse no viable conversion from void to string. What is that? I'm just reversing the string. Why would is this not a function? Okay, just reverse. Okay, yeah, I got it. What? 2 and 0 and 0. I think I am going one letter value. I'm skipping some values. Should I start from the initial value? No. they are working fine. And 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 DP, they are same. Okay, why would I returning that? I don't have to return. Previously I have done the same mistake. Just look carefully. This time I'm getting 8. Excuse me. Why would the answer be doubled? The mistake is, I think, if I done that without giving this value 0. No. Plus 1. I think this is not the condition. Okay. Yeah, it will work. But the case is that uh, in this case, okay, here I have given 1 because now this time we are traveling from traveling and checking the characters one by one of both these strings we have taken. So in previous we have I have checked from first to last, and then uh, if I then this will be the size of and by 2 if I'm checking one like that. But if I'm checking by these A B B B and C B B B one by one, then it will be plus 1 at this time. Okay, I think I will finish this tomorrow. All these questions. What date is 25? Minimum insertion steps make a string palindrome. What? Given a string as in one step, you can insert any character at any index of the string. What this condition? What is this? Minimum insertion steps to make a string palindrome. Okay, we have to insert something to convert the string into palindrome. Given a string as, in one step you can insert any character at any index of the string. Okay, uh, every step you can insert a character at any index. Return the minimum number of steps to make as palindrome. What? Return the minimum number of steps. Okay, you have to return the minimum number of a palindrome string is 1, that is the same. Yeah. And example 1, input s. This is already in palindrome, then you don't have to any uh, apply changes. The string is already palindrome, you don't have to insert anything. And mbatm. Okay, so in this case we can do what I can do. I think here's 2. Okay, so we can't change anything in the string we have given, like b and d. These are different, different characters that present in this index that are not satisfying the condition of palindrome. The m is satisfying, p and d is not, a is satisfying. So I can do what I can do. I have to add one b at a place that can be that can satisfy the condition of palindrome, and similar to d, I have to add d at any position that also satisfy the condition of palindrome. If I put the b, or if I add insert or b at the second last condition and move the d from the last position, means I mean for the previous position, then the b satisfy, I think. And in the condition for the d, I will add a d after b, same as that. I can add anything in anyway. Then this will be the palindrome. Okay, so now I have the Leetcode. Let's go to the Excalibur draw. Leetcode, Leetcode. Now we have this string that have 9 letters, and how could I say that this will be a palindrome if it satisfy all if I am reading from any and from the left or the right, then this will be the same. But here I am checking from the first letter. If I check this from the last letter, that is E, that is not correct, then I can't say that it is a palindrome. Then what I can do, if I found any anomaly, then I will add that at that position, like Leetcode. Now I'm adding L at that position, then Leetcode, and L is at the last position. Now the L I can tell that it's satisfied. Now I can move in both the condition in both from left and right. In left I can increase the counter. I can move from 0 to 1. And this is inserted at the position the index 8. means the size of the string is n, then it can be placed at the n plus 1. Now if I check for this condition and it is true, then I will move to the next condition. If I will check that this is true, no it is not true, then what can I do? I will add e. Okay, so how can I add e? For adding e, I have to push these two letters uh, forward, then I can add e. Okay, but I can add, if I add that condition at that position e, but I have already given the last position, that first position, that this is uh, uh, present at the 8. I think I can't add e at that position. Okay, so I don't think this will work. Do I can should I start from the middle if any character? But if it is okay, this is some serious question. Pam, 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 pam. I think I have just done the 2 question today. But I have learned something. Let's see. Let's is dynamic problem suitable for this program? I think so. And if we know the longest palindromic subsequence is x, okay, if we know the longest palindromic subsequence is x and the length of the string is n, then what is the answer to this problem? It is n minus x as well as n minus x instruction to make the remaining character also palindrome. If I think of the solution of the tabulation, what I have done, I have got the string, and I have reversed the string and stored in another string variable, and I have checked one by one if this string is similar to that string. If it doesn't, equals to that, then okay, can I do that like this? I have a b c, and here I have d a d c. Now if I check this, it's true. Move forward. Now I have the b and d, and if b is not equals to d, b is equals to not d, then I will take another string and I am storing the value at that position. Like first I have checked this condition and I have stored the values. Do I have to store the string. No, I don't have to store the string. Just I have to increase the counter. If I'm not getting this similar value, then what can I do? I will increase 1. Now I have done that. Now I have a string. Now I will move in this position. No, no, I will move this position where I haven't got that. I will move in this condition for the in the second string. Like here I have B, but I haven't found the D. Then I will increase the counter +1 and then move forward. Okay, and move forward in string D. Like I will have at that position. I think if this will be like that, if I have B and D, then I can add the +2 at that position and directly move to the next condition, C, and it can be anything here, but to get these two at the same position, we have to insert two character, I think. And whenever we found, and we will check this place. If it is true, then we will move forward, and if it is not true, then I will add +2 as well. But if it is D and it is also D, I have got here B, and B is no B. I have put it B in that position, like A, D, B. See, this condition is that like that, and now I have the A here, and I have got the D. Like here is B, so I should put B before D. B here, D here. I have put it B here. Now this condition satisfy, this condition satisfy. Now I have D here, and this condition satisfy, and I also have C here, but I don't have anything here. Then I will put here C, and that is the way. But I think there is many ways that medium are marked as hard. That's a medium question. Okay, this is not a hard problem. Also, question must also can be said as minimum number of deletion to make it a palindrome. Okay, this is not that much difficult. If the person are saying, people are saying this is not a condition, I think I am doing the similar thing. I just have to add 2 whenever I found the distinct elements and move forward. Yes, I think so. And let's do this problem tomorrow. Start.